What's going on, smart people? The semester is in full swing again. We're back to the routine of getting weekly assignments, and I figured for today's video I'd go over some of those assignments. Not the specific problems themselves, but what the material covered, how long they took to solve, and then the overall scores that I got on the homework. There are homework assignments that I've turned in that I haven't yet gotten back, which I could wait and then include those, but then I'd also turn in other homeworks on top of that, and now's just as good as any other time. And I figured we'd kick things off with some classical mechanics. The first homework assignment was kind of on a lot of different things. It was like our professor just wanted to make sure we knew the subject still existed. It was 5 problems, the first of which was a problem on center of mass coordinates. It was a derivation. The second problem was the rocket problem under certain conditions. Then we had some telescoping, like satellite problem that was spinning, and it was like a work problem. And then I just moved on to some Lagrangian mechanics. All in all, the homework assignment was about 6 pages. It was just front, not front and back. And then, as you can see, yeah, I hope you can see that, I got a 45 out of 50. Initially, I got a 42 out of 50, but I got points taken off. It said, you did not state which quantities were conserved. And I was like, well, you didn't ask. And then my professor was like, that's a good point, okay. So I got the points put back on. Initially, it was graded by a TA. But now moving on to the second homework assignment. If you want to know more detail about the second homework assignment, I actually made a video when I was rushing to get it done. I didn't go over the specific problems themselves because that would go over university policy, but it's for that reason that I'm not going to go too in-depth on the explanation here. But this one, again, was 5 problems. I don't know if I mentioned that the last one was also 5 problems. And this was all on Lagrangian mechanics. The first problem was coming up with some equation of motion. The second problem was actually deriving the Euler-Lagrange equation, where the Lagrangian also depends on the second time derivative of position, which was interesting. I never considered that before. And then as the problems go on, it would just give you other scenarios and say, solve for the equations of motion. It would be like a ball on a rotating disc, and like, when does the ball fall off? Things like that. Things that you could find in the Goldstein Classical Mechanics book. I don't feel as bad like saying specifically what those problems kind of were because, well, they're straight out of a textbook. It's not something that came out of my professor's head. I'm just not going to be like, and then here's how you solve it exactly. I'm sure you could find solutions for it online, though, if you really looked. But as you can see, this homework assignment took me about 7 pages to solve. It was a little bit over 7 pages. Some of them I let bleed into the back. It took me a while. This one took me a while. But it was worth it because I got a 50 out of 50 on this homework assignment. Initially, I got a 49 out of 50. I did not argue for an extra point. I don't know if the TA graded it and then the professor also graded it on top of that or something, but they corrected their own grade. I am not someone who would argue for one single point. Now we are moving on to mathematical methods. I actually only have 1 homework assignment so far for that. I've turned 1 in and we got 1, but I just haven't gotten that one graded yet. And this one was pretty long and tedious, but it wasn't hard. A lot of the first problems, this was 6 problems by the way, but a lot of the first problem, actually all of it, was proving vector identities, whether that be, for example, the dot product between 2 cross products, or the cross product of 2 cross products, as well as things like the curl of the curl, divergence of the curl, proving those kinds of identities using the Levi-Civita symbol instead of just making some determinant and going through it that way. And though that problem was still pretty tedious, I found how useful and powerful it is to use the Levi-Civita symbol, because when you're just looking for not necessarily a calculation but a derivation, Levi-Civita symbol lets you pick out one arbitrary component, the ith component of the cross product or something like that, which makes it much easier to generalize to the other coordinates or lets you pick a specific case if you want to. But if you're just trying to find a relationship, then it effectively reduces the amount of writing that you have to do by a factor of 3 because you just have to pick out the one component and say that this applies to all of the other ones. You want the x component, sub in x. But then moving on to the rest of the homework, sorry I got a little excited there, the rest got into deriving the basis vectors and spherical coordinates, deriving the gradient operator in cylindrical coordinates, and then some stuff with Stokes and divergence theorem. Overall, it was a pretty easy homework assignment. Like I said, it wasn't hard, it was kind of tedious, but that took me, all in all, about, I don't know if you can see this, but 10 pages, and I got a 60 out of 60. I think that homework assignment, and this actually goes for all of the other ones, could have been way more than those amount of pages, but the thing is I get all of my work done first on this whiteboard, and then I put the finished result that has no mistakes and has all the simplifications onto that sheet of paper. But finally, moving on to last but not least, quantum mechanics. The first homework assignment was all on classical mechanics because we're really building the quantum theory from the ground up. So the first homework assignment was all on the classical Lagrangian and Hamiltonian formalism. So it would be things like giving some Lagrangian, write down the Euler-Lagrange equation, convert to Hamiltonian, find your generalized momentum. And this one took about 10 pages as well, but this one definitely would have taken longer, except for I skipped out on writing out one of the derivations that wasn't necessarily a simplification. It was something that should have been included in my work, but I did not feel like writing it down, so I just screenshotted my whiteboard and was like, if you really want to see the derivation for this part, you can look at that. I have neat enough handwriting to where I didn't think it would matter, and luckily enough it didn't. For this homework as well, I also utilized things like Mathematica to simplify some of the algebra for me, because there would be things where it would be like 3-term quadratics multiplied by 3-term quadratics. I'm like, I'm going to miss a sign somewhere. Mathematica to the rescue. It's kind of weird because this homework assignment was only 3 problems long, so it is a little bizarre to think that that could add up to over 10 pages, but it is what it is. And as for the grade, I got another 10 out of 10, which is nice. The final homework was yet again a quantum homework, which was pretty much all a math review regarding the Dirac delta function, and it was just proving every identity that the Dirac delta function had to offer. So it was one question, 10 parts. The 10th part was actually a bonus where it was deriving it in terms of the integral of the derivative, of the step function using contour integration. And I gotta be honest, this homework was actually kind of tricky for me as well, because you weren't just using the Dirac delta function, you were expressing it as a limit as n goes to infinity of this Gaussian distribution, and proving that in that limit it becomes the Dirac delta function that has such and such properties. So a lot of the things were like Taylor seriesed out, and you had to drop higher order terms, so I thought it was kind of challenging. This one again was about 6 pages, so this was one of the shorter ones, I guess. And when it comes to the grade, I got a 10.6 out of 10, which is nice. The 0.6 comes from the fact that there was the bonus question. I got some points taken off for one of the higher order terms that I guess didn't get rid of properly, so I think it would have been a little bit higher had I got that one correct. But those are the homeworks that I've gotten done so far. I take homework really, really seriously, and I try, actually, I won't turn it in until I know that it is complete and everything is as correct as I can make it, unless something like that happens where I just miss it. It's not a cognitive decision that I've made, like I'm just not going to do this part. I don't do that. I don't believe in doing that. But I hope you guys enjoyed the video. Let me know in the comments section if you did. I'll see you guys there. I'm gonna get started on the next round of homework.